All right, hello everybody. My name is Trevor Conn, and I'm going to be talking to you today about Project Alvarium and the data confidence fabric, and how we're driving that deeper into the stack. I am a distinguished engineer in the office of the CTO at Dell Technologies. I specifically work for the research organization, and my current focus is on edge, zero trust, with a sort of emphasis on platform integrity and attestation, as well as managed infrastructure. I serve on the LF-Edge Technical Advisory Council, and I've worked with two different projects under LF-Edge, the first being EdgeX Foundry, where I was the chair of the core working group for a couple years, and now I'm also the co-inventor of Project Alvarium, and I live just north of Austin, Texas. Okay, so I wanted to give just a brief overview and background of Project Alvarium, because I'm not sure if everybody knows what it is. It's fairly new. So that'll be the first part of the presentation. So Alvarium originated when a colleague of mine, probably about 5 years ago, started looking at this question of data in a connected IoT-driven type of topology. I was working for EdgeX Foundry at the time, and a colleague and I started this discussion around if data is no longer stored in a centralized place. You know, if it originates at one place, it could be handled by any number of nodes and then finally come to rest somewhere else. How could you have sort of an objective measurement, an objective view of the confidence that you can have in that data, that first of all it came from a genuine place, and then second that it wasn't tampered with or affected in some way during its journey. So we wanted to think about how we could define what this metadata would look like for attesting to the verifiable authority of the origin of data, as well as how it was handled. We came up with this idea of trust insertion points, which I'll describe on the next slide. And what we wanted to get to was a measurement of trust that was calculated by virtue of the metadata that we captured at each one of these trust insertion points. And we wanted to be sure that the scoring methodology was flexible enough so that each one of those pieces of metadata could be independently weighted, because not everything is of equal importance. So we take this metadata and apply the weights to it, and we come up with an overall confidence score that we would like to see become actionable, that you can use that score in order to govern system behavior or alert operators to attack, have it be useful in some way. So when you think about the edge environment, data, when it originates at the edge, could take any number of steps before it finally comes to rest, potentially in some cloud somewhere. You know, it could go directly from the edge to the cloud, or it could go through a series of gateways and then maybe onto a on-premise compute node before it gets to the cloud. Maybe it never goes to the cloud, maybe it's just staying within a managed ecosystem. And each one of these points where the data is touched in some way is what we call a trust insertion point. And that trust insertion point is essentially a host running an application that is integrated with the Alvarium SDK. And the SDK is what allows us to gather the metadata and provenance around the data itself. So this is the slide that we sort of use to give people a visual on what Alvarium does. When you have the sensor that's generating data, and in our use case thus far, we're specifically talking about semi-structured data. So this would be data that is coming from one or more sensors being aggregated in some way into a discrete piece of information that is then sent to other applications, like in a JSON format, for example. So that sensor data is coming into the gateway where there's an application running integrated with the SDK, and perhaps at that first step, we are trying to look for three different things. Whether or not there's a TPM on board and what version it is, did the device go through a secure boot process, are the readings being written to some form of distributed ledger, because maybe we want to have immutable identity type of guarantees around the data as it's persisted. From there, the data then takes a second hop and goes to an edge server, which also has an application integrated with the SDK, another trust insertion point. And perhaps we layer on two more annotations, one of which is to say, did the edge server receive the data over an encrypted channel like TLS, And is there a signature on the data that we can validate? Then the data takes a third hop, and perhaps it comes to a cloud node where, again, there's an application that's integrated with the SDK, and perhaps there's a final annotation, which is to say I'm going to validate the content through a hash or checksum to make sure that it hasn't been altered in any way. Now, all of these annotations are published through a pub/sub abstraction. And so there's various backends that you can put onto that, which I'll describe in a moment. But essentially, these annotations are published. There's a subscriber sitting on the back end of that channel, and it processes the annotations in order to come up with a score. Now, as I mentioned before, we like to weight these things independently or provide the flexibility for someone to weight these independently. If we just took a numeric approach, then the scenario that you see here would be a confidence score of 6. And over time, the factors are going to change. There could be more, there could be less. And so numerically, it didn't make much sense. Whereas if you allow for the flexibility of the weighting of each one of the attributes, and then think about it in terms of if everything is satisfied, you get a percentage, then you can have 100% regardless of what it is that you're capturing, how the weights may differ over time, et cetera. So this is essentially what Project Alvarium is today. And if you think about in deployed topology, having all these trust insertion points which are capturing this kind of metadata, then the idea of a fabric, which we refer to here as a data confidence fabric, becomes apparent because you're essentially collecting metadata from all these different data streams that are proliferating through your environment. And that data stream is sitting on top of a deeper compute stack, which I'll talk about that in just a moment. The SDK interface is very simple. I will go into more about how this is used on the following slides, but essentially we facilitate capture of metadata when data is created, when it's being transited from one place to another, if it's being changed, mutated in some way, and whether it's being published out to an environment that you don't control. We also have this fifth method in here, the bootstrap handler, that's specific to the Go SDK and is used to clean up resources and do initialization and things like that. Now the schema is somewhat flat, and it has sort of developed over time as we've put more features into the project, and it's sort of defined in such a way that allows us to demonstrate the concept. But I wouldn't say it's been formalized in any way. It's still open for discussion and extension. We talk about that a lot actually on our TSC calls about how could we potentially vary this so that perhaps there's something like an envelope message type of format that would allow us to vary the message that's inside, relating that more tightly to the different verticals or perhaps a customer use case. So the schema as it is today is just very simple. And we're trying to capture, first of all, what kind of annotation is it? We need to uniquely identify each annotation. We need a way to be able to link it to the data that it's describing. What host did it come from? We sign each individual annotation as well, and then there's an indicator, second from the bottom, as to whether or not the annotation is satisfied. The thing that the annotation is looking for, was that condition met? And it's key that we don't have the annotation coupled in any way to what am I trying to say? To decision logic. In other words, everything that the annotation needs is passed into the annotation in terms of the data, and anything from the compute environment is passed into the annotation. The annotation is a discrete unit that makes decisions strictly based on what it's given. It's not like someone is in there doing complex if this, then the other thing in order to say that the annotation's been satisfied. We really want it to be by virtue of what is represented in the compute environment. There's two other properties that we've added on there, tag and layer, and this allows us to move these annotations deeper into the stack, which will be the second half of the presentation. Okay, so in an actual environment, this represents a lab that we have set up, and we've got 3 different nodes. We've got a far edge, we've got a near edge, and we have a core node. The customer's data is not affected by the way that we capture annotations. We wanted to be very clear about the separation between the customer's data and the path that the annotations take. We didn't want to interfere in any way or have the customer try to change their data path or their data schema in order to take advantage of this technology. Their data is their data, right? And we shouldn't be invasive in how they do their processing. So when data is created, let's say at the far edge, for this particular example, that's going into a Mongo database. That's the customer's database. The annotations, however, are going a different path. They're going through this stream that I described earlier, and a couple of the different providers that we have on the back end are things like Hedera or MQTT. We could also integrate with Kafka, streaming data platform. The point is that it's a pub-sub abstraction. So if you have a distributed ledger like Hedera, like IOTA, that offers that kind of semantic, then we can absolutely publish the annotations to a distributed ledger. On the other hand, if you don't want to use a distributed ledger, you could just use a simple broker like MQTT, or you could use Kafka or NATS or anything that you wanted, sitting as a provider for that stream. And sitting on the back of the stream, we have a subscriber and a whole calculator. I don't have the time to get into how that algorithm works, but we build a graph for the relationships between the annotations and the data that's sitting in ArangoDB right now, and I'm going to show you a picture of what that looks like in a moment. So the way that this lab setup works and how we utilize the SDK is as follows. So on the left-hand side, in the far edge node, we're going to be creating some data. And we've got two different annotators that we're looking for there. Is the data signed? That's the PKI. And is there a TPM on board? Now, all these are VMs, so there is no actual TPM. So those annotations are going to fail. You can see going from left to right that there's no TPM on any of these. On all three, however, there is a signature that we can validate, so you can see that PKI is going to be yes going all the way across. Now, the first handoff from the far edge to the near edge will not be done with TLS. You can see there in the middle, TLS is no. But the next handoff from the far edge to the core, TLS will be yes, because we will use an encrypted channel for that. And there's essentially an HTTP post that's going from far edge to near edge to core. So the way that you would use the SDK for these trust insertion points is the data is created. Your application receives that data, and it's going to save it into your application data store, MongoDB in this case. At that point, you would call create on the SDK, and you would pass in the representation of the data as bytes into the SDK, along with anything that you think is important contextually from within the environment. So create is passed there, and the annotations flow through the stream. Next, your application might hand the data to another node to pass it upstream. That's going to be transit on the SDK, it's simply a handoff. Now let's say that that application does some sort of mutation to the data. Perhaps it augments it in some way. Perhaps it transforms it. We can track through the use of the mutate function on the SDK the generations of data, so that you could have your original data, which then got transformed to a second generation of data, which got transformed to a third generation of data. And we can record all of that in the graph database along with the relative or relevant annotations and the score for each step in that generational evolution. So again, after the data's been changed, we're passing things up to the core node now. Another transit occurs. And finally, we're going to take this data and we're going to publish it to an environment that we have no control over. That's what publish is for. So publish allows someone who's using the SDK to say, okay, I sent you this data, and at the time that I sent it to you, I have all these different checks around the underlying compute environment in which the data was generated that I can attest to. This is the view model that we build in ArangoDB. And each one of the purple dots that you see represents a pointer to a piece of data. All of the blue dots that you see are the annotations related to that data pointer. And then the black dot is the score. So this is essentially the output of the scoring algorithm. And it may be difficult to see, hopefully you can see it, but there is an arrow going from the top purple dot down to the lower purple dot. And what that means is that the top purple dot is a child of the lower purple dot. And one of the things I'd love to see in the future is a data flow that has kind of this fan-in, fan-out type of representation. I think that would be interesting to have all these different inputs come together into a single piece of data and then see where that single piece of data is being utilized in other use cases. But this is essentially the view model that we build. And you might be thinking to yourself, well, how do you take this and relate it then to the customer's data? So you'll notice that on the purple dot, there's this long hash. That is the hash of the data itself. So remember I said it was semi-structured data, perhaps in a JSON format, that we have hashed. I think the algorithm here is SHA-256. And if that data in the customer's database is not tampered with, it will always hash to the same value. So what we're able to do then, if we wanted to put together a dashboard that shows the customer data along with an associated confidence score, we have an application called the populator, which will go through and read for the customer's database for new entries, hash those up, do a lookup in a RangoDB to find the score, and then put those together into a read-only view model that you can then use to drive a front end through an API, which will then query that view model and show you the data with the associated confidence score side by side. And again, if someone has gone in and modified the data manually in some way, the hash value will be different. And so you'll have data with missing confidence scores, which could indicate some sort of problem. Okay. That's the first half of the presentation. That's what we do today. And now I want to talk a little bit about where we're going, what the next iteration is. So I talked about how if you have all these trust insertion points in your environment, the data is flowing on the top of a stack, and so we give it that sort of metaphoric name of a fabric. When you then start to penetrate deeper into the compute stack, we're thinking of that as there's more nodes that are now starting to become involved. It's not just about the applications anymore, the trust insertion points. It's about the underlying compute as well. And so now we're thinking about this more as like a data confidence graph. This is the conceptual diagram of how this fits together. And everything that I've talked about so far sits in that data layer. So what we would like to do is to think about how does the underlying compute stack condition the data and how it's handled. How does the CI/CD process that builds the artifact which you deploy into your infrastructure condition the confidence that you can have in your data? And so we're working through how to build these linkages where the application at runtime that's generating the data has the ability to link itself back to the artifact from the CI/CD pipeline using a tag. We should also then be able to know that the application is running on some instance of a VM or OS, whether that's a container or whether that's an actual VM, or it could be a native OS too. Being able to link the data to the underlying host. We already have somewhat of the ability to do this, but it's not explicit. We're making it explicit. And then finally, the instance of the OS is running on some physical piece of hardware. And we want to be able to annotate characteristics about that physical piece of hardware and the OS environment that's running the application that's then tied to the CI/CD pipeline. So this is where we're taking the project. This is also, I mentioned that in our annotation schema, we've got these two new properties that we've added recently, layer and tag. Layer is essentially one of those four that I just showed you on the previous slide. So where the annotations are happening, we have visibility to know what layer of the stack we're operating at. And also the tag values help us, they're contextual based on what layer we're at so that we know, okay, is this an actual physical host identifier? Is it just an OS host name? Is there a SHA that's associated with the commit that the application is sourced from? Being able to link all of those things together through the tag and through the layer allows us to build this graph. Our current focus right now is on iterating the scoring algorithm to incorporate and relate these additional stack layers. We've already got V1 of the scoring done, but now we need to incorporate these other levels into how we build the score for a given piece of data. And we're starting with very simple mechanisms in order to be able to capture those annotations, because we need the annotations in order to revise the scoring layer. So the mechanisms that we're using right now from an open source perspective are very simple, and I'm going to show you those on the next couple slides. The other thing that's important is, as this thinking is evolving, it's changing the format of the SDK. And one of the things we realized early in the project was it's not feasible for us as a project to maintain all of the annotators that people are going to want. We have to have the ability for people to leverage the SDK to facilitate this workflow, but they should be able to define their own annotators. Because, for example, you may have an annotator relative to your environment that has something to do with your business context or some form of IP that you don't want to contribute to an open source project, but we should be able to facilitate that creation through the SDK. So some of the benefits that we see of this approach is, number one, increased observability. If you're publishing this stuff into a ledger, then you have this immutable identity-driven log of the infrastructure attributes. There is an explicit proof and auditability of your infrastructure integrity at the time that data was generated. It's my experience that a lot of the security guarantees and things that we talk about are implicit, in the sense that if something goes through a secure boot process, well, great, the box is up, so I know it went through a secure boot process. But there's nothing that I can actually point to at a given point in time if a bad piece of data is generated and some problem happens because of that. We want to see, well, what was happening in the environment when this bad piece of data was generated, or an anomaly or something like that. Having that explicit piece of metadata that says at this time, yes, we had gone through some sort of secure boot or any other kind of secure configuration that you have in your stack, I think could be very important. To that point, we are looking to sort of facilitate some of our thinking around zero-trust deployment and management, as well as infrastructure measurement. We think that there's an opportunity for people to use this as a monetization aspect, because if you're generating these large data sets that you then want to use to train a machine learning model, you have a couple different data sets to choose from. One of them has all this provenance, the other one doesn't. You know, are you willing to pay a little bit more for that trust? And so can you then also have a higher level of confidence in the machine learning model that is running if you know that it was built or trained using data that has this level of trust associated with it. So talk a little bit about the CI/CD pipeline. We've integrated with Jenkins, and you can find all these annotators in our Java SDK. Essentially, the way that this works is that every build is treated as an individual data point, and because it's build 1, 2, 3, 4 for the same artifact as changes come in. And so some of the things that we thought about are, well, when the clone happens from GitHub, or your provider of choice, the first thing that we want to do is, after we run the tests, we're about to build the application, is we want to verify that the code we're about to build has not been tampered with since we cloned the directory. And so that's our first annotator that we sort of have put into the pipeline, is the source code annotator. And then secondarily, we have a vulnerability annotator that looks through the dependency file, and we support right now Maven and the Go mod. Looks through there and then goes out and queries the open source vulnerability database to see, are there any vulnerabilities associated with the dependencies. So that's the second annotation. Then the next one is an SBOM annotator, which currently today uses SPDX format, but you could put CycloneDX in there if you wanted to make a contribution. And the SBOM annotator makes sure that the software bill of materials that the developer has uploaded with their PR matches the dependencies that are present in the file. And then finally, from an orchestration perspective, if you publish a tag with a checksum on the artifact that you built, let's say you're using a Docker image, and you have your orchestrator come along and pull that image, number one, it can look for any level of confidence that you've already assigned to that workload, but it can also annotate that the checksum that I have received is the one that I'm expecting, and that was published from the build pipeline. So that's how we're annotating the CI/CD pipeline. Now, from a host perspective, the scenario that we've set up is essentially a Linux host. We're just looking at Linux right now. And again, this is the physical host that we're trying to capture information on. So we have a DCF agent that spins up along with systemd when the box starts. And for now, it's going out and it's reading things like the machine ID. It's looking at UEFI to see if secure boot has happened. It's querying the TPM to see what version it is and if it's enabled. And then it's also looking at things like, well, what OS is running on the physical host? And so we take all these annotations and match them to the physical host and put that into the graph. From an OS VM, it's pretty much the same thing. The trick here is if you're using a VM, passing in the identity of the physical host into the VM so that you can make the linkage between the VM and the host that it's running on so that you can have all of that in the graph. But for right now, so that we can capture the OS level annotations, we're doing the same thing that you just saw on the last slide, looking at the host name and then the flavor of OS. So all of this is essentially coming together to provide what we think is a deep level of introspection and the ability, like it's not something that you're going to look at all the time, but if there was an event that occurred, some way to de-risk your operation and you wanted to look over time and actually see the level of confidence that you can have in the data that your enterprise is generating and what goes into that confidence, you have the ability to do that. And again, all of the different annotations that we capture at the different layers of the stack as part of the scoring algorithm are mapped to a policy. So in that policy, you have the ability to weight all of these things independently according to what's important to you. So finally, these are the resources. If you're interested, if this sounds like a neat idea and you want to sort of play around a little bit with it, we have a project website. Our GitHub organization is project-Alvarium. We have 4 different SDKs, Go, Java, Python, and thank you to the Demia folks for contributing the Rust SDK and the Rust example application. The example applications show you how the SDK works, so you're not just trying to figure it out on your own. All the scoring apps that we currently have for the first cut of the algorithm, they're all in the scoring apps repo. You can go take a look. And when I was showing you the 3 nodes that we had set up in a lab configuration and talking through how the SDK works, those are all available in the repo at the bottom there, which I made available for this conference. So I've used up all my time, so I don't have time right now to do Q&A, but if you have questions and you want to discuss a little bit, it's lunchtime, so I'm happy to chat with everybody. So thank you very much for coming. Appreciate it.